Hey everyone, so we're going to do 8.2, which is radian, degrees, coterminal, and reference angle. This will actually help us before we get into the unit circle, just like last class when we did the special right triangles, which will also help us with the unit circle. So angles can be measured using two different measurements, okay? Degrees, and that's what normally we're used to when it comes to circles, and what's called radians. When converting between the two measurements, we use proportions. Just like you would say with time, right? If I converted 4 hours into minutes, I would say, well, I know that there are 60 minutes in every hour. And because 60 minutes in 1 hour is the value of 1. Now you want to make sure that you're putting that ratio in the correct form. If I put hours over 60 minutes, well, I don't get rid of the hours because hour over hour is 1. Hour times hour is hour squared. So whatever we start out with, that's going to be in our denominator of our ratio when we actually calculate this out and we calculate straight across. So when we think of that one unit, or how 60 minutes equals 1 hour, they're equal. You can use the fact that 180 degrees equals 1 pi. Okay, so that's the ratio we're going to use. So when I'm converting 30 degrees to radians, I'm going to multiply it by, now since we're going from degrees to radians, degrees is going to be on the bottom here. And I know that pi is 180. Now I'm going to multiply straight across. What you could do is when we multiply straight across, we end up getting 30 pi over 180. But we know in our calculator, we can reduce that. Do not use your pi. Go 30 divided by 180, and we get, did I put 130? Oh, I put 18. Sorry, guys. Be careful that you're pressing it incorrectly. 30 over 180. Wow. Equals, and math, enter, and you get 1/6. So when simplified, we still get pi in the numerator and 6 on the bottom. So 30 degrees is pi over 6. Okay, so let's keep going. Again, we're dealing with degrees. So our degrees is in the denominator. Multiply straight across, we get 225 pi over 180, but we can reduce. So 225 divided by 180 equals, now I'm going to put it into a fraction, so math, enter, and get 5/4. So that means this is 5 pi over 4. Do you guys see how that pi is there, but I'm not using it when I put it into my calculator? Let's keep going. All right, 405. Well, 405, that's at least once around the circle, right? Because how many degrees is a circle? 360. So 405 divided by 180 equals, math, enter, 9 pi over 4. Oh, we have a negative. What does that do? Well, for now, when we change it into radians, it just makes it a negative radian degrees. In a little bit, I'll show you what that means on a unit circle. Okay. In your calculator, if you want to put that negative in, go for it. But other words, you know that radian is going to be negative. So 270 divided by 180. And then math, enter, we get 3 pi over 2. All right, what if we were going backwards? Okay, so we're in radians. So you see that pi because that's radians. So what did I say before? When we multiply by that proportion there, we put our unit in the denominator. So we're going to put the pi in the denominator and the 180 degrees on top. Now what I want to show you is the reason why we do that is because pi over pi is 1. So those cancel. So in your calculator, you're saying 180 divided by 6, which is 30 degrees, which we should know that because it was right up there, right? All right, let's do this one. Okay, I know the pi's cancel, so don't have to think about it. But now this is a little bit different math. Remember, multiply straight across. So 3 times 180. And then we're going to divide by that denominator of 2. So we get 270 degrees. Okay, times 180 over pi. Pi's cancel right away, so I don't even have to think about it. But again, I'm going to go 20 times 180 and then divide by that denominator, which is 9. So we get 400 degrees. Oh, we have a negative over here. So we know it should be a negative degree. Pi's cancel. Again, it's okay if you put in the negative or you don't. Sorry for the glare, guys. So I get 16. Can't do it with my left hand now. 16 times 180. Divide by that denominator. Okay, so math, enter, enter. I'm going to double check this, guys, just in case. So in this case, because I know that this does not come out very nicely, I'm just going to say negative 2,880 divided by 7 degrees. I know that looks weird, but it's totally okay as long as your process is correct. Okay, that's converting. Now let's talk about sketching these angles. So in order to sketch the correct angle, there are a couple of things we need to remember. First, we will always start at the positive x-axis. And that's where we start. Hopefully this is in the right direction according to the video. Positive angles go counterclockwise. Negative angles go clockwise. If an angle measure is in radians, use the denominator value as the number of pieces in a half circle. So in other words, when we divided it by 6, that means we had 6 pieces for half that circle. Break apart pieces of the entire angle with ones you know, like 90, 180, 360. So 137 degrees. So remember, we always start at the positive x-axis. So we're going to start here. I'm just going to pick a point, put it right there. Now I'm going to move 137 degrees. So this is, remember, whole circles 360, which means a half a circle over here is 180. A fourth of a circle is 90. 137 is a little bit more than halfway between 180 and 90. So 137 is going to be right here. Yep. So usually to indicate your measure, you end your measure with an arrow. So we know that we started here and we went counterclockwise. We went counterclockwise because it's positive. All right, 17 pi over 6. One thing I want you to keep in mind is, remember, we're starting on the x-axis, the positive x-axis. It's positive, so we're going counterclockwise. What I also want you to keep in mind is that this is pi, and when we reach back around, this is 2 pi, 3 pi, 4 pi, so on and so forth. So the first thing I want you to realize is that 6, right? 6 would be 1 pi, 12 would be 2 pi, 3 pi would be 18. So that means we're going 2 pi and 5 more added on to that. So to show that, we go fully around. Now to show that I go fully around is I actually don't want to connect it, because if I connect it, I think I could go around there a bunch of times. So this is 2 pi. Now remember, we're going 5 more, right? Because 12 pi over 6 leaves 5 pi over 6. Okay, so 5 pi over 6 is going to be over here, closer to another pi. Okay, so this tells you you went 1 rotation around, which is a full 2 pi, and we're going to go a little bit more. Okay, 245. First of all, I want you to see that it's more than pi, so it's more than half a circle, but less than 3/4. Okay, so, and we're going counterclockwise. So I'm going to start at the x-axis positive, but I'm not going counterclockwise. I'm going clockwise. So half a circle is 180. And if you needed to in your calculator, you could say 245 minus 180 equals 65 degrees. So we're going 65 more. We're going to be here. Now watch, because I'm going clockwise, that arrow is on the other side. And that's how you know it's a negative angle. 4/3 pi. Well, first of all, we have 1 pi in there, because 1 pi would be 3, right? Leaving 1 more pi over 3. And we are going counterclockwise. So start at the x. We're going 1 full pi. And then we go pi over 3 more. Actually, it's going to be over here. Okay. All right. Coterminal. Coterminal angles are the standard position angles with initial side on the positive x-axis having common terminal sides. For example, 30, negative 330, and 390 are coterminal. And I'll show you. 30 is right here. You see that? See if I can get another color here. Instead I had green. Let's just use my pencil. Negative 330, well, remember that is clockwise. Now, as you can see, if I go negative 330, I end up at the same spot as 30, but from another direction. Do you guys see that? So I end up in the same spot as 30, but in a different direction. And we can keep going with this, because if you see 390, so counterclockwise, that is a full rotation plus 30 degrees more. What happened is we all ended up in the same spot. So these angles are what we call coterminal angles, because they end up in the same spot. To find a positive and negative angle coterminal with a given angle, we can add and subtract 360 from it. So if I gave you 45 and I said, what's an angle that's coterminal to that? You can either add 360 to it or even subtract 360, and those are coterminal angles. Now, of course, when it comes to radians, you're not going to add or subtract 360. You're going to add or subtract 2 pi, because 2 pi is a full circle. Reference angle, I'm going to introduce to you right now, but you're going to mostly use it with the unit circle than you will in the practice work that you will be doing on big ideas. If you do the practice worksheet instead of big ideas, you'll have to practice some of these, okay? Sorry, this cord's in the way, guys. Reference angle. Associated with every angle drawn in standard position, there's another angle called a reference angle. The reference angle is the acute angle formed with the terminal side and the x-axis. Okay, so these give you position right here. So see how this is 60 degrees. If you see, we could make 60 degrees come off of the x-axis, but going in the second quadrant right here. This is a coterminal angle, but we can reference it with the 60-degree angle. Same thing with quadrant 3. It's 60 degrees from the x-axis, 60, well, this one's 45 in this case, but we wanted to do 60. I guess we printed that wrong. So let's sketch these angles, find some coterminal, and then also look at the reference. So negative 130, right? So it's more than 90. And it's less than 180. Okay. So negative, start on the x-axis, go clockwise. So 30. So that 130 is going to be around here. So what we can do is take negative 130 and add 360 to it, and we would get a coterminal. Negative 130 plus 360. So a coterminal angle would be 230. Now, if you see the directions tell you to give a positive and negative. If I added another 360 to there, what would happen? We would still have positive. So let's subtract 360. Okay, so negative 130 minus 360 equals negative 490. Now, how do we get that reference angle? Well, think of this. If this is 90 and we went 130, how many more did we go? Well, we went 40 more. But that is not the reference angle. The reference angle comes from where it hits the x-axis. So if this is 40, how much do we have here? We have 50, because remember, each of these quadrants is 50 degrees. All right, one more, guys. Oh, we're doing it in radians. 5 pi over 6. 5 pi over 6. That's close to 1 pi, huh? Well, so it's close, but it's not there. So we know it's counterclockwise. We're over here. Okay, so 5 pi over 6. Now we're going to add 2 pi to it. Now here's the tricky part, guys. We're adding fractions, which means I'm saying 5 pi over 6 plus, if I needed to get this over 6, I would have to multiply that by 6, which would be 12 pi, equaling 17 pi over 6. And then we would do the same thing. We would subtract 5 pi over 6 minus 2 pi, which is actually 12 pi over 6. And that would give us negative 7 pi over 6. Now reference angle. Remember, reference angle is to the x-axis, which is down here. Well, if this is 5 pi over 6, how much do we need to get to 6 pi over 6? Because 6 pi over 6 would just be pi, right? Well, that means our reference angle is 1 pi over 6. This really does help us. Let's practice these little skills first, and then we're going to connect everything together in 8.3 and the unit circle.